Hey everybody, hope everybody's doing well and is healthy and safe. We're gonna start here this next section here, 3-4. We're gonna discuss how to solve some exponential and logarithmic equations. I'll break this up into kind of two lessons and two bookwork assignments and things, and wrap it up with some worksheets and things like that. Probably a week's worth of work here. Okay, so we're going to get started here. So you will need a calculator. And again, one benefit of this, you can pause this at any time, rewind, do what you got to do to kind of understand the material. Make sure to ask me some questions, send me any messages through Google Classroom or an email. And also I'll be having help sessions weekly, if not more than once, if you want to discuss anything or have any questions on anything. So don't hesitate, okay? Or even just stop by and say hey to see other people and everybody else. You will need a calculator with this, probably something to write with, or write down and try a couple problems and things. I may tell you on a few of these, hey, press pause right now, try this problem and such. All right. So first thing we're going to talk about here, mostly we're going to deal with just exponential equations here, but I will once or twice talk about logarithmic ones. Basically, these first ones are what we would call kind of a one-to-one. Actually, we've kind of already done these ones when we first started dealing with logarithms and things like that and exponentials. So a one-to-one idea is, if I had an equation of a to the x equals a to the y, then we know x and y have to be the same. In other words, if the bases are the same on both sides, then the exponents have to be the same. So that's what these kind of first ones are. And the same is true with logarithms. We've already seen that, and that's one of the logarithm ones we're going to look at. And we're going to come back to this one-to-one idea with logarithms, even with more complex ones, okay? So again, if you're taking a log base a on both sides, log is the logarithm of the same base, then we know what they're taking logarithms of have to be equal. Okay, so let's take a look. So for example, this one here is a one-to-one idea. Is 3 to the x equals, and then what you want to do, and this is what we've done before, think about what is 81 with a base of 3 to the what power? Well, that would be 3 to the 4th power. You have to kind of grind it out and think about it. So these are kind of fixed. So then that means, of course, x is 4. Okay, so again, if you're looking at this and saying, oh, it doesn't look much different than before, you're right. They are kind of very similar to the same idea. So we're not going to do a lot of the one-to-one. We're going to get more into how do I use a calculator and solve those ones that are more complicated. All right, so this one here, let's see, we have 1/2 to the x. Well, how could I make these the same? Well, at first glance, you're like, I don't know if I can, but this would be 2 to the 4th. So some of you might be able to get that answer right now, but what we can do is if we change both of them to be the same base, this would be 2 to the -1 to the x. And this is 2 to the 4th. And then remember, when you have a power to power, you multiply. So this is 2 to the -x equals 2 to the 4th. So -x equals 4. X equals -4. Okay, so that's kind of the idea. The idea that I'm trying to show you here is if you can change the bases to be exactly the same thing, you can just set the exponents equal to each other. Okay, and this last one here of a one-to-one is a logarithm one. And so what we want to do there is get it to look like this up here. To do that, we're going to add ln 10 to the other side, and now they're both taking the natural logarithm of the same, so then that means x equals 10. Okay, and we're going to come back to this in the next video in particular and talk about this idea of getting things to look like this, ln of x equals ln of 10, and so that we can just set those equal and solve. All right, okay, so next then is, well, what happens when they're not that nice? Like look at that number one there. I think we've even seen this one before and talked about it. 2 to the x equals 7. There's no way to change 7 to be 2 to some power. All right, so then we're going to have to use inverse properties. Remember, when you solved an equation, something simple like 2x equals 7, you always did the opposite. Well, the opposite of multiplication here, we have multiplication, is division to both sides. And so that's why we get x equals 3.5. All right, so the opposite of an exponential is a logarithm. All right, and the opposite of a logarithm is an exponential. Okay, so in fact, to solve these problems, we're going to use this property over here, this fact that if I have a log base a of an 8 and an x, in a sense, what's happening is this stuff is canceling out and we just get the x. Same is true here, but we're going to come back to this one. This is what we're going to use for logarithmic equations. That'll be in the next video. Okay? And again, the ideas are a to a logarithm base a. These things cancel out, and we just get x. Again, we'll come back to that. So the idea here is this is exponential. What's the opposite of an exponential? A logarithm. Okay? So we have to take the log base of the same base there. So base 2 on both sides. Okay, you're taking the logarithm. Remember, it's the same idea that we just did over here. It's the opposite. The opposite of an exponential is a logarithm. Well, what happens on the left? Well, this here is the same as this here. These all cancel. This stuff right here kind of cancels out, and we just get x. So then we have log base 2 of 7. Now, we have to figure that out. Sometimes you can leave it like that, but in most cases we're going to want a decimal. So remember, we got to go to the calculator. There's two ways we can do this. The easy way here on this calculator, the TI-84, is if we went to math, and then this one, you're going to use log base, and we would put a 2 in and a 7, and we'd hit enter. Okay, and we get, 2.807. So x equals 2.807. Well, what if you don't have that calculator? How do we do that? Well, we can use the change of base. So what we can do is we can say ln, or we can use the log button. We can say ln of 7, parentheses, divided by ln of 2, and we should get the exact same answer. Okay? You could use the log button as well. You could say log 7 divided by log 2. This is what we learned in the last section. It's called the change of base formula. So either way works. So if you don't have this calculator here, if you just have a basic scientific one on your phone or online or on your computer, you can use the change of base to get your answer. Okay? All right, so back to this one. Now this one's a little bit easier. These are nicer in the sense of, well, what's the opposite of this? E to the x. Well, it's a logarithm base e. Well, remember, log base e to the x is actually just an ln of x. Okay, so we're going to take the ln of both sides. Okay, and again, it's like this cancels out, and this just gives me x. Okay, and so then we have x equals the ln of 50. Well, that's a little bit easier, and most calculators can handle that. If I clear the screen here, so we just say ln 50, and we're going to enter. So 3.912. Okay, all right. And so those are kind of basic models. The next couple examples that I have are just kind of variations of this. Well, what happens if there's other stuff here? But I mean, really, this is the base. This is the new stuff. The rest of it is algebra skills that you pretty much know. So let's look at them. So if I look at this problem right here, number 3, well, I got to get the exponential part by itself. I got to get it to look like number 1 that we just did previously, which was 2 to the x equals 7. Okay, so to do that, I first want to divide by 5. I don't want to multiply the 5 and 3 and get 15. Order of operations wise here, this is 5 times 3 to the x, not 5 times 3, and then to the x power. So the first thing we would do is divide both sides by 5, so we get 3 to the x equals 20. Okay, now this is an exponential, so the opposite of that is a logarithm of base 3. So we're going to take the log of base 3 of both sides. Okay, again, the left, we just get x. On the right, we have log base 3 of 20. So we got to go to the calculator again, because I don't know what that is. And again, it doesn't matter how we do it here. I'm going to do it in change of base form. Sometimes I think it's less button pushes. ln 3. Oops, I forgot my divide. Divide. Yeah, I got to redo that one. ln 20. ln 3. All right, 2.723, we'll say. Oops. 2.723 is my x. All right. So for number 4, maybe you want to pause this one and try it on your own. Remember, we got to get this by itself before we take the logarithm both sides. So why don't you pause it and try this one. All right, so let's try this. So the first thing we would do is subtract 6, right? I'm going to actually show some of the steps here. So then this will be 2 to the 4 to the 3x plus 1 equals 9. Then we're going to divide by 2. So we still have that equals, and that's 4.5. Okay, and we can leave it as a decimal. You could have done it as a fraction as well. All right, so next we are going to take the log base 4 of both sides. It's always the same base as whatever that base is. Okay. Well, what happens here? Cancels again, right? So this kind of goes away. 3x plus 1. Now we have to get a decimal for that to make our life a little bit easier. All right. So what was it again? 4.5 log base 4. All right. Yeah, I think this one, just to change it up, we'll use the log base on the calculator. Make sure I type that in right. Yep. Enter. And enter. 1.085. 1.085. Okay, so now we have to solve for x. So 3x equals 0.085. And then we're going to divide by 3. All right. So what do we get there? Well, I'll subtract 1 first. And then divide by 3. So 0.028. Okay. All right. So again, what are we doing here? Well, when we have these equations, we have to get the exponential part by itself first. All right. So do that. Remember, those two things are kind of tied in together. So we got to solve that first. So that's what we did here. All right. That's that step. Then we take the logarithm of both sides of whatever the base is that's being raised to that exponent. In this case, it was a 4. Over here, it was a 3. Previous problems, it was an e or a 2. Okay, so that's the logarithm that you take the base of on both sides. Okay, all right. Last question is a little more complex. All right, so it's going to take us a little bit. All right, and I'm giving you a couple of these to try homework-wise, or bookwork-wise. I shouldn't say homework-wise. Everything we're doing is homework-wise. All right, so it's a quadratic type. What do I mean by that? Well, you know, it's like this: y squared minus 5y plus 6 equals 0. Well, how do you solve that? Well, you have to factor it, right? Okay. You have to factor that. Well, how does that factor? Well, in this case, it's going to factor into y minus 2 and y minus 3, right? That gives me the correct answer, because negative 2 times negative 3 is positive 6. Negative 2y, negative 3y gives me negative 5y. All right, so then what are the answers to those? Well, you know, you normally would y minus 2 equals 0, y minus 3 equals 0. So y is 2 and y is 3. All right, well, how does that translate to this? Well, look at this closely. I'm going to rewrite this a little bit. I'm going to say this. I'm going to say e to the x raised to the second power, and then 5 e to the x plus 6. Now, I'm going to not get too crazy with these. We're going to kind of keep them as e's, because if there are different numbers, it gets a little more complex. But I want you to notice this is something squared, right? Something squared, and then minus 5 something. Isn't that what this is? Something squared minus 5 something. So it's going to be the same thing. The difference is, instead of y minus 2, we're going to factor this into e to the x minus 2, and then e to the x minus 3, and then equals 0. Okay, so hopefully you can kind of see the connection between what we did previously with the y squared minus 5y plus 6 and this. I think it's helpful to kind of bring that up. You don't have to do this step right here. You know, you can, once you see this problem, just factor it. I've given you 2 of these to try, so come back to this if you have to and look at this example as a guide. Now we have to finish this, so what we do next? Well, we take each of these and set them equal to 0. Right? Well, how do we solve that? So e to the x equals 2. And then what do I do to both sides? It's the opposite of an exponential is a logarithm. So I have to take the logarithm of the same base, so that's an ln of both sides. Okay? So this one is ln of 2. If I go over here, and we'll come back and get the decimal for that in a minute. And then this one, I'm going to take the ln of both sides. So this one is the ln of 3. Okay? So I just need to get those two answers. Okay, so we go ln of 2 and get an answer, and then ln of 3 and get an answer. Get an answer. I'm trying to hit the enter and it's not working. All right. So that means this answer for ln of 2 is 0.693. And this one is 1.099. Okay, so those are your two answers for that problem. Call this a kind of quadratic type because it is quadratic in nature. All right, so the idea there is to factor. Like I said, I'm only going to give you a couple of them. Most of the other problems are like the previous problem. So let's see where I do have this assigned. Oops. There it is. So page 221 to 222 in the book, 17 to 29 odd, 45 to 50 all. 17 to 29 odd are kind of the one-to-ones. Those first couple examples we did, they're kind of the ones, and you don't have to do it that way, but 45 to 50 all would be the ones where you take the logarithm on both sides. 55, 56, same thing, and 61, 62 are those last couple problems. All right. Good luck on that. Try that. I'll post this assignment as part of a separate assignment as I have been. I'm also going to include the answers to those problems so that you can kind of look those over after you do it. And that's the way I'm going to do things from now on. Okay? All right. Any questions, let me know. Take care, everyone.